Hello everyone. In this video we're going to be solving an exponential equation. We have 27 to the power x equals 1 over x. So I'm going to go ahead and show you how to solve this problem. We're going to be using a little bit of calculus. We're going to make a table, we're going to look at a graph, and at the end we're going to be looking at another graph. So we'll analyze this in different ways. First of all, as always with these questions, if the answer is a rational number, then you can kind of guess and check. If it's irrational, it's harder to find. So let's go ahead and start by raising both sides to power 1 over x. So that's going to give us the following. 27 to the power x to the power 1 over x equals 1 over x to the power 1 over x. Now, where does that motivation come from? First of all, I want to get rid of the x on the left-hand side. And also, I do see 1 over x on the right-hand side, which is also another motivation because by doing this, we're actually getting the same base and the exponent on the right-hand side, which is cool. And also, we get rid of the x on the left-hand side. So killing two birds with one stone. So here we go. We get the following. Let's go ahead and write what's on the right-hand side, on the left-hand side. So kind of switch sides here. Write this as 1 over x to the power 1 over x equals 27. So this is nice. And I'm pretty sure you already guessed the answer, right? Okay. We do know, by the way, I forgot to say, but we do know that x does not equal 0. So I was able to raise both sides to the power 1 over x. So that's allowed. Now, we're going to go ahead and use substitution, because I really want to show you how you can analyze a situation like this. So let's go ahead and set t equals 1 over x. This implies t to the power t, and by the way, I like t. I like coffee too, but t is better, in my opinion. Anyways, t to the power t is equal to 27. And yes, t is equal to 3, right? Obviously, it's not too hard to guess, because 27 can be written as 3 to the third power. So from here, by correspondence, we can tell, or we can say that t equals 3. But does that guarantee that there's only one solution? In other words, we have a function. Let's go ahead and define it as f of t equals t to the t. Is this always increasing or decreasing? Let's go ahead and check it out. So we're going to differentiate this function to find out whether it's always increasing or decreasing, or what the intervals are. I'm going to differentiate it. But how do you differentiate this? This is kind of like a weird function where the base and the exponents are both variables. So we kind of have to do something first. Let's ln both sides. I know some people use it e to the power something, something, same thing. Anyways, I just like this method better for some reason. So now we can bring the t down. That's the cool thing about ln or any log. T ln t. Now this is nice because we don't have any variables in the exponent, so everything looks good. When you differentiate ln of a function, right, you have to use the chain rule. ln u, differentiate it, u prime over u. That's the rule. And remember, we'd use this for integration too, backwards. Great. Now, let's go ahead and differentiate it. So it's going to be f prime, whatever the derivative of f with respect to t, and we're going to divide it by f. U prime over u. And on the right-hand side, we have the product rule. So derivative of t is 1, multiplied by ln t. The derivative of ln t is 1 over t, with respect to t, of course, times t. So from here, t cancels out. And if you multiply both sides by f of t, you get f of t multiplied by ln t plus 1. But f of t is t to the t, lots of t, times ln t plus 1. Now, next step is going to be setting both sides equal to 0. Because when you set the first derivative equal to 0, so this is what we're looking for. We're looking for a point where, or points, where the function has horizontal tangents. What happens when you get a horizontal tangent, and if you have a smooth curve, you're going to have a maximum or a minimum. Even if you don't have a maximum. Well, if you have sharp corners, that's a different story. Anyways, let's not get into that. Let's just keep it simple. By setting this equal to 0, first of all, t to the t cannot be 0. It's impossible, right? So we're going to set the second factor. This implies ln t equals -1, and that implies t equals e to the power -1, which can be written as 1 over e. So we have something at that point, a maximum or a minimum. We're going to find out by making a graph, but first of all, let's find out the f value at that point. F of 1 over e is going to be 1 over e to the power 1 over e. So you can guess that's going to be a small value, right? Obviously less than 1. We have a fraction raised to a fraction power, kind of like the root of a fraction. Think about it as, I don't know, square root of 1/2, right? It's less than 1. Okay, great. What am I going to do next? I'm going to make a table, like I said earlier. Let's go ahead and make a table. So our table is going to look like this. We're going to have t, we're going to have f prime of t, and we're going to have f of t. And our critical value here is 1 over e, which makes the first derivative equal to 0. Now we kind of have to find out what happens to the right and to the left of 1 over e for t values. If t is greater than 1 over e, for example, you can kind of use a test value like 1. And our function, remember, the derivative is t to the t times ln. So let's go ahead and write the derivative here real quick. T to the t multiplied by ln t plus 1. If you replace the derivative with 1, you're going to get 1 times ln 1 plus 1, which is positive. So to the right, we know that it's going to be positive. You only need a test value. Obviously, 0 is not a good choice. And 1 is, I think, a good choice. So it's going to be negative here because it's going to change sign at that point. So that means our function is going to be decreasing on the interval negative infinity to 1 over e. And 1 over e to infinity, it is going to be increasing, which means we're going to have a minimum at t equals 1 over e. Great. What is that supposed to mean? It just means that our function or graph is going to look like the following. We're going to have something like this, t and f of t. So we're going to have, and obviously at 0, it's not well defined. So I know some folks say, hey, 0 to the power 0 is 1. No, it's not. Anyways, it's going to decrease first and then increase and goes like this. So this is 1 over e where we have a minimum, and f of 1 over e is 1 over e to the power 1 over e. It's a fraction or some number that is less than 1. So what is that supposed to mean? So we're looking for a function. This is f of t equals t to the t. And we want t to the t to be 27. So obviously, we want the intersection point of the horizontal line, t equals 27 with this. There's only going to be one intersection because our graph is increasing on 1 over e to infinity. All right? So we're going to have a single solution. And that is going to be what? Okay, so that's what we're going to find now, right? And we already found it, actually. T equals 3. Wait a minute. We didn't find the value. Okay, so let me write the original equation, and let's back up a little bit. So we have the following equation. We found t equals 3, and our substitution says t equals 1 over x. So x must be 1/3. You can go ahead and check it out. Replace x with 1/3. 27, cube root of 27 is 3. 1 over 3 is right. The same answer. Okay, let's go ahead and take a look at another graph now, and we'll finish up. So I graphed 27 to the power x and 1 over x. Obviously, one of them is increasing, one of them is decreasing. They're going to intersect at a single point, and that is where x equals 1/3. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.